because I have just a few introduction things to say before we start our presentations today. Here's number one, don't miss Monday's class. Yesterday there was a puppy that got weaned. He's going to be here Monday. One of my past students is coming up, bringing him. I don't know if it's Siberian Husky, some husky. I saw one picture of it. You know how a new puppy is. Probably has that new puppy smell, right? Going to be here Monday if all goes right? You know how that goes. Fingers crossed. And then there's some of you that are presenting next Monday. I've got the list. I'll show you at the end of the class. People like Cole and so forth. I won't say names because that thing's recorded. But all of you, I'll give you your assignment right now at the end of the hour because I have a busy weekend, and so rather than send out individual emails like I usually do, I'll tell you people your assignment at the end of the hour. Another logistic things, I got the exam finally all done, graded in the spreadsheet, but I didn't have time today to duplicate them and then fold them, and hand them back, so I'll do that next week. Most of you had the answer key and you know where you're at anyway. Okay, so then one last thing. We talked about this Monday, and somebody said 800 parts per million, right? And that's neat, because not neat, it's terrible, but it's neat that a lot of times they don't report what the level was. So, I'm not sure the story. It's a hotel. It's privately owned, by somebody, but that you can use your name if you pay some franchise fees. But can you imagine the lawsuits going to come out of this? And maybe the hotel owner goes, well, we didn't, by law, we didn't need a carbon monoxide detector. Because a lot of times, if you're built before a certain date, then you don't have to go back and meet the code that used to be, the new code, right? But you would be totally stupid if you had a hotel with a pool that was heated by something and you didn't have a carbon monoxide detector. You just said, they'll probably go out of business with all the lawsuits, right? I mean, why would you do that? So that's crazy, but I think there's a number of them. I think 5. Okay, I think there was something about, I'm not sure if it said here, one person died, one young kid died, but then there were like 5 or 6 that were unconscious. So what a terrible scene that was. And I just can't not harp on these things because that's stupid. Okay, I think I said that enough. Let's go here, right? Come on up. I'll show you how the pointer works. And take good notes. Look at that. Let's see. We're probably going to have to maybe. You want to do the link right now?
Yeah.
Okay. Great. Okay.
Okay, so I had thermal conduction, just like defining it and talking about it, what it is, kind of more in a physics aspect than animal science aspect. So that first bullet point is the actual definition. So a transfer of heat by microscopic collisions of particles and movement of electrons within the body. So the rest of it is just kind of summarizing this, where it's heat transferred by conduction is when those atoms are vibrating against each other or making like micro collisions with each other. It works best in solids versus in fluids and gases. There are other types of kind of energy transfer that work better in fluids and gases, but conduction works best in solids. The particles that are colliding, I'm sure most of you have taken physics at some point, so the particles that are colliding are always in constant motion. That's what's giving them the kinetic energy. The kinetic energy is what's going to kind of actually cause the conduction to happen. Based on the articles that we are supposed to read for class is the third big bullet point.
Try that little green vertical.
Okay, yeah, this one. So the types of motion are that there's wigglers, according to this article, and that there's bangers. And then the wigglers are vibrating in fixed position, whereas the bangers are kind of moving across like everywhere and then hitting things as they're moving, whereas wigglers are kind of fixed in that same location. And then when the particles collide, whatever particle has the most energy is going to lose energy when it collides with something that has less energy, and that particle with less energy is going to gain the energy from collision, and that's how the actual transfer is happening. And then the kinetic energy from these particles is what's going to transfer into thermal energy. Because when you say it's the transfer of heat, obviously the kinetic energy isn't the heat, it's when it transfers that it causes thermal energy. That's going to be the actual heat that's, it's referring to.
Are you going to show the other one? Okay.
I'm going to show the
other, whatever you've got. Okay.
So these are the two animations that come with the article. So when it's talking about it, like gives them little like speech bubbles as to which particles, which kind. So that's kind of an example of how the particles are working. And then this one down here is that the blue one comes in with more energy. So it's going to cause the white one's temperature to increase, while the blue one's going to lose that energy that we talked about. So the temperature will decrease.
And as she's talking, my hand is experiencing exactly what's on the screen. The coffee cup, I feel warmth from the coffee inside. So it has to be warmer than my skin, and I know that heat only travels from high to low. And this is it. Now she started out, and her assignment was tell us about conduction, but take the physics viewpoint. And then the next speaker will talk about maybe how animals use it. But you've got it, and then at the end, after we do 6, I gotta summarize a little bit about this stuff. But this is conduction. You think of it as she well stated, solid objects, but everything is still. You don't see anything moving. It could be water too, as she talked about, or a gas. But here's the thing: still conditions. Nothing's moving that you can see, because that will be not the case with some of the things. Conduction, excellent. Person number 3, go by the door. We're so efficient. And I have these things hopefully lined up. That's yours, right?
Yeah.
Notice the green vertical line.
Which one?
The green vertical line. I know it's hard to see.
Okay.
Here we go.
Okay, so basically, like she said, conduction is the transfer of heat between two solid objects. And basically, where this heat goes, it depends on how hot one thing is. So if you have something that's hotter than the other, the heat's going to transfer to the cooler object or animal. So some examples of this, like one that I think of, is when you have heated rocks for reptiles. So they're going to lay on them, and basically the heat will go to them. Or when you have like a dog that lays on cool tile or something else like that. And in that instance, then the heat's going to transfer to the tile because it's cooler.
And Stella does that so well. Because when she gets hot, she's smart because she doesn't lay on her chest. She lays on her side, and you're going to find out that one of the factors that influences how much heat is transferred by conduction is what's called the effective surface area. So she puts her whole side down.
But yeah, basically they have to be directly touching the object. They can't just be floating above it.
Right. Yeah. There's got to be contact.
But yeah, the rate of conduction does depend on the surface area of contact and the thickness of the objects, whether it's like hair or scales. Like a lizard's gonna be filled cooler faster than the
Now,
rock
in your
will.
example, the lizard must be hotter than the rock, because notice how the arrow, conduction is taking heat from the lizard to the rock in this case.
Mm-hmm. And the thermal conductivity of the objects, what this basically is like how metal, you'll feel how hot it is faster than you will wood sometimes, even though they might be the same temperature.
Okay, so now remember, we're partners. So she alluded to a great factor. It's called the conductivity of the conductor. That sounds like you went to college, doesn't it? I want to talk about the conductivity of the conductor. And here's the kicker. If you're a good conductor, you're a poor insulator. If you're a good insulator, you're a poor conductor. So sometimes you want things to move and sometimes you don't, right?
Yeah, it basically just describes how fast the heat is going to transfer within the object.
Mm-hmm.
So you're going to feel how hot metal is pretty much, or how cool it is right away, rather than just something like wood or fabric.
Mm-hmm. And there's actually tables, and we'll show you next week. There's a table, and metals differ by what lead versus copper versus aluminum, and it's called the conductivity of the conductor.
That's the end.
That's your story, you're sticking to it?
Yes.
Okay, very good. Number 3, come on over. Number 4 is going to the door. We are so efficient. do the arrow. That's yours, right?
No. I just emailed
Oh,
one,
no,
so-
go ahead. Oh, do one more.
Yep.
Here we go.
So I'm talking about like the physics side of convection.
Okay, now we're on to convection.
So convection is basically the heat transfer from one place to another by movement of fluids. This could be like water or air.
Or blood.
Yeah, or blood. It's when, so like in this example, the heat
Here's the green. It's not very distinct, but that green little. There you go.
So in this example, the heat rises from this hot water and it goes up, and then the cold water fills the place where the hot water was. So that's how it gets heated. Convection uses the combined processes of conduction and advection. So conduction is the heat diffusion, and advection is the heat transfer by bulk fluid flow. And there's two ways that convection can happen. One way is called forced convection, and this is like when the movement of the fluid is forced, so like a water pump in a vehicle or
Or a
through
fan.
yeah. And the other way is natural or free, and this is when the motion is caused by buoyancy forces that result from the density variations due to variations in the thermal temperature in fluid. So that could be like this example with hot and cold water.
So you guys are so surprisingly good. You know, we don't rehearse this at all, but she talked about the natural convection or free versus force. And force always has something like a fan, something mechanical is usually moving it. But your heart is a pump, so your heart is pumping the blood, and that would be convection. So perfect, and she took the physics approach. That was her assignment with convection. Person 4, and then 5 goes to the door. Remember who 5 was? There we go. Okay, go to the next one. Is that yours?
Yeah, that one is this one.
Okay.
So as you said, the convection is the transfer of energy or heat through like water or air. So the example I use with animals is like a fan force heater you put in like a large barn. Especially in my family, we have like a swine barn, so that's what we use. So the fan uses gas to make the heat, and the fan pushes the heat out, and it just covers the whole area of the barn until it gets to a certain heat and it shuts off. So when it lowers beyond the temperature set, it turns back on to get the heat to rise. And it just kind of works like that.
Mm-hmm. And so there's a thermostat involved, right?
Yeah.
So remember, we don't rehearse this. Every animal has a thermostat. There's a tissue that monitors temperature in all of us in this room, and the puppy that will come Monday. Where's the thermostat at? What tissue acts as a thermostat?
No, it's in the brain.
Well, good. Your brain?
Is it the hypothalamus?
Hypothalamus. Very good. See how, almost like pulling teeth a little bit.
Take it like 6.
Yeah, hypothalamus is the thermostat for the body. And we're going to find out that there's 2 reasons why body temperatures rise. And if there's a certain case that you can't call it a fever. Okay? And this, go ahead, you can sit down. This was your picture though, wasn't it?
Yeah, but I also have just a normal picture of a heater.
Okay, yeah, that's fine. But the point is, here's another take-home message with this one. Look at how many things are happening simultaneously. So we're going to talk about all these mechanisms, and we'll kind of introduce them in an isolated sense. But in the real world, they're happening. And since this is being recorded, let me just go through this. You're okay. So we're going to talk about how, somebody's going to today talk about thermal radiation. That's what this really is, reflected sunlight. Look at wind. Something's moving. It's a moving medium when you have convection. It might be wind, it might be blood, it might be water. But it can't be still, because if it's still, that's conduction. If it's moving, it's convection, and a lot of times it happens at the same time. Okay, direct sunlight, scattered sunlight, evaporation, somebody's going to talk about that today, infrared radiation from the atmosphere. And then see, you can get heat radiated to you, or simultaneously you can radiate heat to other things. That's a great diagram there. We are set for the next person. Number 4, right? 5? You're 5. So number 6 needs to go to the door. I'm losing track here. Do the right arrow and probably, that's yours, right? See how well we have this planned out? Try the pointer. Got it? Here we go.
Okay, so mine is thermal radiation, and the definition is it's a form of heat transfer where electromagnetic radiation is emitted from the object due to its temperature. It's a full spectrum, so it's several different like wavelengths and everything. And then like by color, like matte black is a much better like emitter or like emitter, and silver is going to be a worse emitter, but in vice versa, black's going to be a worse reflector and silver's going to be a better reflector. It says absorber also. It's kind of the same thing.
Well, it's the opposite. So if you're an emitter, you're emitting to something else, but if you're absorber, you're taking it in. So it ends up being black is a great emitter, but it's also a great absorber. Okay? So I mean, I love that diagram, and look at you guys, you find these things without me, so it's super. Go ahead.
Okay, and it's more or less just trying to explain that like certain surfaces, certain types of color, everything affects the way that this thermal radiation takes place. You know, you could have something that's black, but depending on whether if it's matte or shiny, it changes its ability to absorb and emit the electromagnetic waves.
Mm-hmm. And this is the only heat transfer mechanism that has anything to do with color. Notice when we talk about conduction, we didn't say anything about color. Convection, we didn't say anything about color. But color plays a big role in this thermal radiation, which is electromagnetic waves. If you're ever around a Holstein cow on a sunny day, there's black, great absorber, and then right beside that black patch is a white patch, the least absorber. And you can put your hand on the black and the hand on the white, and they're different temperatures on the same cow. And he took the physics approach,
Yeah.
because that was his assignment. Tell us about thermal radiation from the physics viewpoint, because person number 6 is going to tell us about how animals, right, do this. Practice that. See that little, I wish that green was better.
Okay, well once I turn this in, I kind of realized that it's more infrared than thermal radiation, but going off of what he just said, if we wanted to look at thermal radiation in animals, you could still look at the animal coats. If you have a dog that has black fur, they usually get hot a lot faster, and I know that from having to groom outside. I usually have to like set up practically a tent to keep them cool and spray them down all the time. And then dogs with lighter fur do not get hot as fast. But basically what this was showing here was how animals use the fur to keep themselves warm, which I still thought was pretty interesting. When you look at like the infrared cameras and stuff that you put on them, that orangish yellow color is their heat that they're kind of emitting. But
And you can
their
see on the
fur is-
scale on the right, the yellow is warm and the dark is cooler. Yeah.
Yeah. But since dogs are warm-blooded animals, it does work like that. But this is a caterpillar, and I guess they're cold-blooded, so they aren't able to make their own heat. They kind of just get it from their environment, which is why they're the same color as like the surroundings.
That's okay. Talking about light and solar
Right.
radiation and stuff, yeah. Anything else?
No, it's probably
Okay. Yeah, and she made a good point about, next week we'll talk about infrared radiation. Here's the kicker with that. That is an exception. That is colorblind. So if you have an infrared heater, it doesn't matter if the absorbing surface is white or black. Infrared is colorblind, but regular sunlight is not colorblind. It depends on the color, how much is absorbed. Okay, we're set. Let me just try to, you find your slide and I'll see if we can get that down a little bit. Sorry. No, that's okay. Let's see. Okay, I guess you guys can still see up there. Here we go. Okay, now, let me, before you start, draw a line in your notes. Everything we've talked about before, these three things, conduction, convection, and thermal radiation, is called sensible heat transfer mechanisms. So, sensible, those three up there are sensible. And here's the thing about those three that are above in our notes. An animal can gain heat by those mechanisms, or an animal can lose heat by those mechanisms, all depending on the certain conditions, okay? And they're called sensible because at the moment of heat transfer, you can detect it with a thermometer. Now below that line you just drew, what's coming up is called insensible heat transfer mechanisms. Insensible, sometimes called latent, L-A-T-E-N-T, latent heat transfer mechanisms. Latent is a term that means hidden. So why is it called insensible? Because it was always, a bugaboo of mine. Here's why it's called insensible. Because at the moment of heat transfer, the temperature doesn't change. That is so freaky. What changes is the phase of the material. So when we go from solid, or like, let's say liquid water, to a vapor, that's called a phase change. And at the moment of that phase change, if you measured the temperature of the water and the temperature of the vapor, they're going to be the same temperature. The thermal energy went into the phase change at that moment. And that's why it's called insensible heat transfer mechanisms, also called latent. It's hidden. The thermal transfer is hidden at the moment of the phase change. But of course, then we know that she's going to talk about evaporation. Are you going to talk about evaporation as from the physics standpoint? Or?
You wanted the definition from
Okay,
physics, but
okay.
then you wanted it with animals.
Okay. So yeah. Oh, that's right. Yeah, because it's not quite as neat as the other ones. Okay, take it away.
Okay, so here's like the summary of the kind of scientific one, where it's just like a liquid state of a substance goes into the gaseous state due to like the ambient temperature, which I had something over here.
It's the next one.
Okay.
Go ahead if you want to look at
Okay.
it. There.
Yeah, but like this is a good definition thing, and I didn't want to like plagiarize, so I just took a screenshot of the website and gave it credit. But yeah, so like it's the ambient temperature goes above the body temperature, and like yeah.
Okay.
So, but like how animals are affected by it, it's like when they get overheated, they like horses sweat, as we talked about on Monday. But yeah, and I don't know if this is actually what it's scientifically called, but elephants, like splash water on themselves, and it's kind of like sweating, where it's like the same thing, where when the water evaporates off of it, it like takes the heat off of it. And then we know dogs pant. And what I found on one website, I don't remember exactly how it works, but there's like nasal passage cooling, and I thought that was kind of cool, so the brain doesn't overheat. But yeah, that's all like evaporation on animals.
Okay, evaporation. So we're doing a phase change. Okay, and Lauren, are you here?
Yeah.
Lauren, you're going to do something with evaporation too, right?
Yep.
Okay, we'll do Lauren, and then we'll see what we can summarize. Come on over. You were done, right?
Yes.
See that little green there?
Yeah, okay.
Perfect.
So I just have an example of evaporation that animals use for thermoregulation, and that is panting. So all of you guys have seen it in dogs. But what I found interesting was that it also occurs in many mammals. Most birds actually use panting, and then some reptiles use it also as a mechanism for cooling themselves. And so as she mentioned, this evaporation is when liquid turns to water vapor, and this has a cooling effect. So the way this works is the molecules on a surface evaporate, and then, like Dr. Aldrich mentioned, thermal energy turns into a different phase, and then this is a cooling effect. So panting results in increased respiratory frequency and then decreased tidal volume, which tidal volume means the normal volume of air intake that a dog or any animal would have at rest. So basically it's the fast breathing, but they're shallow, short breaths. And this allows increased airflow across the tongue, mouth, nasal passages, and upper respiratory tract so that the moisture in these areas can evaporate, and then heat is transferred out of those areas. And then blood flow around this will kind of take that cooling effect throughout the whole body. So this is just a fun fact. Dogs can reach up to 300 to 400 breaths per minute by panting, and their normal rate is 30 to 40, so it increases a lot. And then also they have a way of panting with minimal muscular effort, so they can do this without actually adding on a bunch of heat. So
That's a good point she makes. A lot of times when you try to get rid of heat, you end up generating some heat. And next week I'll draw a little figure that talks about how the thermal neutral zone. But a lot of times, remember how if you're going to try to get rid of heat, sometimes you generate heat at the same time, but you generate less than what you get rid of. So the net effect is you lose heat, but it ends up being you're going to generate a little more heat to get rid of that other heat. Okay, very good. Okay, so now I'm going to just do a couple other things since she did such a great job here. So the point is, evaporation is a phase change. And remember the first three mechanisms, I said an animal can gain or lose heat by those three, those sensible ones. Evaporation, it's only a one-way street. You can only lose thermal energy this way. There's no way you can gain thermal energy from evaporation. Okay? So this is a one-way street. You lose heat by evaporation. But what's the total opposite of evaporation? There's a process that's the total opposite. The first three mechanisms don't have opposites. There's nothing opposite of conduction. Maybe you can say there's no conduction, but there's something, the total opposite of this. This is going from liquid water to water vapor, but what if you did vapor to liquid? What's that called? Condensation. That's the fifth heat transfer mechanism we talked about today. Some wouldn't even talk about it because usually it has nothing to do with our animals. Condensation, okay? Maybe you'll see some water vapor condensing on a cow, maybe someplace. If you're familiar with pipes in houses, sometimes the pipes drip, right? It's not liquid coming from inside the pipe going out. That dripping pipe is condensing water vapor on its surface, okay? And whenever you see condensation happening, that object is gaining heat. Because if it takes, like if you evaporate a gram of water off a surface and that loses, let's say, X amount of energy, if you condense a gram of water on that surface, it would gain that same amount of energy. So evaporation is the total opposite of condensation. Those are the two insensible heat transfer mechanisms, but a lot of people don't even talk about condensation because it has nothing really to do with our animals unless you see some, water beating up on a furry animal. The other thing she mentioned birds also pant, but in birds you don't call it panting. What's the term for panting in birds? It's a two-word phrase. Any poultry people out there? Okay. So it's called glular, G-U-L-A-R, space flutter. Glular flutter, G-U-L-A-R, flutter. Don't ask me. Well, it's because of they're basically panting, but it's called glular flutter. Okay. Anybody else have any questions? Anything? Come Monday to see that beautiful puppy. Doesn't get any fresher than that. Start studying for exam 4, right? It's a great time to start studying for it. Stay dry, it's still raining out there.